A couple of things that I wanted to share. Let's see, share screen. Let's see, what screen are you seeing? Why is this such a challenge? Oh, there it is. Yep, you're getting the right screen.
Oh,
are you getting Slack?
yes, that's the guy. That's my post.
Yeah, that's your post. I was going to focus on this one over here. Trying to get MoveBase to run on the RPi. So basically for me, you know, I've got a tractor that's under digital control. I'm trying to run a mission, and I'm trying to get the software organized such that I can run a mission. And so what I worked out is MoveBase for me, I think.
I'll do you listen me?
Go ahead, Juan.
Yes, I don't understand what you are showing. I'm seeing a Slack window only. Or you are yes. Now I see. Sorry, I'm using the phone because I got bad connection, so I wasn't seeing that that you were working in the side of the window. Okay, sorry.
That's okay. So previously using the simulator, MoveBase was running in the simulator and was running on the laptop, and I needed some help to get MoveBase running on the actual RPi. So I reached out to Vinny and he helped me get that moved over to the RPi. And just to be clear, this is this particular Python program, which is inside of lawn tractor navigation. I mean, this is the guts of this is the code that, you know, gets a goal, you know, monitors for a goal, gets the path, executes a path. And so where this runs, you know, physically on what platform is you know, a substantial sort of architectural discussion. Okay. Anyway,
I don't understand. This is when you were asking about where was the test planner coming from.
Well, I mean, maybe you understand all this. I didn't, so I had to figure out in my own head where this code was going to physically run, because up until last weekend, this was always running in the simulator and in the Docker container.
Yes, I didn't understand that too. I'm in the same page like you. That's why I am asking about the test planner.
Yeah, this is just a part of all of that.
Okay.
I'm only pointing this out because this is a critical part. That is, the actual code that's getting the path and executing the path. And so for me anyway, it was just helpful to get down to where is this actually running. And so what Benny helped me work out is, and what I wrote down in these instructions, was cloning the development branch, logging onto the RPI, cloning just the development branch. Then there's this submodule that has to be updated. And there's a dependency update that has to be run. Because it was on the RPI, because the communications was a bit dodgy, there were errors that we had to run through. And then we had to go through a process of creating a launch file to separate out what was previously in, the simulated world, what was going to run on the RPI, what could be deleted, and what was going to run on the laptop. So that's all been written down. And so then I went into, my startup procedures, which are still basically the same. I launch on my RPI, I launch my sensors, I launch the joystick, which is connected to the laptop, I launched the NEMA driver, the GPS. This says RViz, but it's really the TEB planner or and it all works now. If I go back to Slack, the evidence I have of that is so I had my tractor sitting in the yard. It was getting a GPS signal. It wasn't running. The transmission was disengaged. But I was able to have RViz running on the laptop, TEB planner running on the RPI, and be able to, give a 2D nav go from the laptop, and it, generate a command velocity output.
That's a command velocity ROS topic.
Right, that's what this is up here.
Okay.
So I basically just asked it to go straight forward, a few meters. Now,
okay,
I didn't turn it on and physically move it because I was chicken. Because you can't cancel this other than to shut off the whole tractor. There's no cancel button that's programmed into this. So before I physically was going to do this, I wanted to spend a little bit more time figuring out how to cancel it, which there isn't a cancel process programmed in yet. So the only way to stop this once it's started is to shut down the tractor. So that's where I'm at.
Al, some concerns about what you are saying. First, have you looked up the bring up launch file?
Yes, I can. So in
No. I'm talking about if have you relook that file, because as you are relooking all your setup, maybe there are things that you can bring up to that bring up launch file, as the EMEA and those kind of things. You can set them up or turn it on when you launch, when the tractor goes up in the launch file. That was one of the things that I was trying to do too.
Yeah, I probably can. I mean, at the moment, just for you to know, I put my my entire RPi Ubuntu folder is out on the G drive.
Okay.
So it's more than just the Catkin workspace. So the launch file will be not in that one.
Okay.
I mean, this is the current launch file. So it grabs that URDF. It brings up move base flex. This is the MBF behavior tree program that I mentioned earlier. And these are the two transforms that it creates,
Yeah,
so that it
I
has
don't have the I don't have it like that. I have a specific ROS bring up launch file.
Oh, I'm sure you could help me with making this better, but this is what I've got so far.
Okay.
So that's the only. I've got this broken down into 4 or 5 pieces. So that's where I'm at.
Well, if nobody's going to keep on, I will tell. As I told you in other meetings, I'm working with a guy that is it's like an apprentice working here, and we catch up the tractor, and we are working through every sensor individually, and we finish that line of work this Thursday. we have problems with one of the odometry sensors, and we have problems with the potentiometer that was taking the steering wheel position. I got one of the wires cut up, and I didn't notice that, and that was one of the problems that I was getting. So as I'm convinced that that is something that I can solve for the community as like a sensor check script. So now, as we get the control of the sensors, now we are going to build a script only for the checking of the sensors. That will do a sequence of testings in the sensors when we got problems with the tractor. So from that point of view, I will get the data of perhaps if the potentiometer is it's broken, or got a wire that is cut, and the odometry sensor that was one of the others that I got problems is giving. I get a lot of problems with the noise of that sensor, but we put a resistance to cut up that noise. And the other thing that I was getting problem, well, I don't remember now, but we will build up a script that will check up the sensors. So from the Raspberry, you can upload it to the TKInter via the command line interface for Platformio. That I don't remember. It's what's the name of the PIO? It's called PIO. It's a command line tool that lets you upload the main CCP script. So we are going to build another script to test the sensors and the things that are managed by the TKInter. I think that we will be working in that next week, and we are beginning to deploy the sensors in a breadboard, in a big breadboard. We are going to put it like Chef got it, and the script that we will test the sensors. We will begin testing the script in that breadboard, and then we will translate it to the tractor. So my line of work for the next, I think, 2 or 3 weeks is that we are being able to work 5 to 6 hours straight with this guy. And the other thing that I'm building is we are going to build a little robot with this, and that was what I put in the Slack channel. It's the NOAA project that is like a clonical of the Turtlebot. That's something that I'm working in the other group on the Spanish user ROS group, and we are working. I think that 4 hours a week in that project too. And I think that that's all the things that the news that I have for this.
That's great.
Yes. Something that I'm missing is to update the Google Drive repository, because I'm thinking that I got some errors there what I uploaded.
The testing that you're doing, are you doing that with ROS, publisher and subscriber statements, or are you doing that outside of ROS?
No, no, that's a second. It's like here we are going to, it's a very good question, but because I didn't explain it. First of all, we are going to test up the hardware, and then we are going to test up the, we are going to build another script that will test up the topics, the ROS system, because it's like much easier to get the console, the logs for testing the hardware, and then as you get the hardware right, you can pass for the topic. So you are sure that you got the hardware right, and then you go to the software. Because that was something that we found out that you can have problems in both areas. So first of all, clean up the hardware and be sure that you got the hardware right. And then you will go to the software part on the ROS system.
So the user interface, if your steering angle sensor is not working right, what's the user interface to tell you that? I mean, is it?
It's the serial terminal, like all the Arduinos. You will look it in the serial terminal. For the moment, what we are looking, surely the first prototype that we are going to build, it's not so a big project. It's something maybe it's very stupid, but for us it's very important because we get a lot of time stuck in that kind of problems in the robot. So we will try out to get that script and get the. It's like when you load up your software to the Arduino or the TKInter, you get the serial terminal, so you can see what is happening in the TKInter or in the Arduino. But as when you try to optimize the code, you always block that kind of thing to not to show up. You get the debugging information out of the statements of the code.
Yeah, the reason I ask is because I never know how to TKInter, I think is how it's.
What are you saying? Yes.
I think that's how you spell it.
TKInter.
Yeah, this
I don't
little
know.
this screen is what I programmed to get results back on from ROS topics.
Okay.
These,
yes, that's important, and surely that will be very useful for us in the second part when we are going to debug the software. But first, we have to be sure that the sensors are working and we are getting good data from the sensors. When we finish the sensors, we will go for a script like yours.
And what I'm trying to understand is you're just getting text data back on your terminal screen, is what you're saying now?
Yes.
Okay.
Yes. That's what when that things were something that were maybe an error because I didn't have in that moment the knowledge that I have now about Arduino. Now I'm getting better because of the other project that I'm working, the IoT project with the weather stations, and I'm getting very confident about that. And one of the things that we work a lot in the other project are the statements that the sensors give us, the temperature sensor, the wind sensor, and that kind of things, to try to debug it. And that's one of the problems sometimes when you're working with hardware. First, you have to be sure that the hardware is working, and then go to the software, because all for example, these are things that are going to happen. If you are working with the tractor at the field, you will get the bumps, you will get all that kind of things, and the wires will break, and you will have problems. So you all, in my case, when I got the problems, I didn't know which were the problems, and that takes me a lot of time trying to understand which was the problem that I was having, and that's something that always I'm repeating in ROS. It's not something easy to get the when you are escalating the system, you get a lot of sensors, you get a lot of software working together, and when you have a problem, it will stop completely, and you will not know what is happening unless we try to build up a script that let us test the sensors, the actuators, the steering wheel motor. That kind of things are very important to get solved as we are working, because we will have problems. It's inevitable that we will have problems when we are driving the robot.
I agree. I mean, definitely, I agree. I've been there too. That's why I've got a very basic, simple sort of feedback mechanism there. But
yes, but and I think that must be something that doesn't have to be so complicated to translate to get it for the other tractors, for your tractor or for every tractor, because the only thing that you will have is like a run-up script that will test each sensor and will get you a feedback at the end. It's like ROS, what the fuck? Did you use it? It's like a debugging tool in ROS. It's ROS WTF, and you get information from ROS. Sometimes it gives you good information, sometimes it doesn't give you good information, but it's, at least you have a tool. But I didn't have a tool to test the hardware, and the only tool that I got was trying to get information from the topics. And when you didn't have information from the topics, you go to test which was the problem, but you don't have a tool. If you got a wire that is cut, you have to test each one of the wires to. So I'm trying to solve that.
makes sense. Anything else, Juan?
No, it's not easy to show what I've been working, because I feel that I cannot show something because it's very basic what we have done. But we are working in a good rhythm. We are pushing the issues once a week. We are killing 1, 2, 3, or 4 issues that we have about this, and I think that in 1 month or 2, I will be able to show more about the work that I'm trying to accomplish.
It all takes time, doesn't it?
Yes.
Write down your steps. Write down your steps.
Yes. Yes. I got them right, because but I got them in Spanish. I'm pushing the code that I'm testing to GitHub. It's very stupid code. It's not fancy code, but I will push all the code to GitHub. No, that's not the problem. The problem is that we get, for example, one of the things that I got wrong was the odometry sensor, the magnetometer. I got two different types of magnetometers. I don't have here. One is, wait a second, one is 3 wires and the other one is 2 wires. Wait a second.
Now you're talking Jeff's language.
No, but I felt very stupid about this because I was for a week working with this sensor. This one, the magnetometer sensor, for me is very important because I'm trying to get odometry from all the wheels of the tractor. So by now I got only one, and I bought this one that got 2 wires, but the tractor got one that got 3 wires. I thought that they were pretty similar, but they are not similar. So we lose a lot of time in this, but now I get the code for the two ones.
Did you look up
the other sensor that you got? Yes.
Did you look up did you find the part number and look it up so you've got the actual data sheet so it tells you what those wires are doing?
Yes. But
You-
one of the problems was that I thought that I have done that right, but I didn't do it right.
The other thing to be
this one
careful
you
with,
got,
the other thing to be careful with, if it's a 2-wire sensor, that probably means one of those is the power wire. If you hook up to 12 volts, don't connect that to your microcontroller or you'll blow it up. Your microcontroller can only take, say, up to 5 volts input. So depending what those 2 wires are doing there, you're going to have to be careful about. Don't just wire it into a microcontroller pin. You're going to start blowing things up. Do you have the part number for that 2-wire
no.
sensor?
Yes. Let me.
We could
Wait
pull
a
up the
second.
data sheet and look at it.
No, because I pull it. I solved it. It's the LJ18A3/8/Z/EX. It's like this. But it's not a problem now. I solved it, but I didn't solve it. The guy that is working with me solved it. Now we can use the 2 sensors. This one is hooked up to the Arduino because it works with 5 volts from the Arduino Uno that we are using to test the sensors. In the setup that I was talking earlier. Well, that's all. This is a very common sensor. They use it for the 3D printers and that kind of thing. But the tractor got one very similar, but with 3 wires, and you hook up 2 of the wires to the battery, and the other one is the wire that gives you the data. So you don't have that kind of problem, but you have to put some resistor to cut out the noise that brings the sensor.
So in this case, Juan has it all figured out, but for everybody else, I'll just make the statement, when you get a new sensor, be careful about what you're doing, because if you're powering the sensor off 12 volts and you plug it in your microcontroller, you could blow out your microcontroller and everything, all of your other electronics. So it depends how much money can you afford, blowing things out. So whenever you get a new sensor, make sure you know exactly what it's doing and know if you connect it to 12 volts, is the output pin going to be putting out 5 volts or 12 volts or something else? Because if it's putting out anything, if it's putting out beyond the range of your microcontroller, you can destroy a lot of stuff instantaneously. So just everybody keep that in mind. Whatever you're trying to connect to it, make sure you know exactly what it's going to do before you plug the wire in, because afterwards it's too late.
Chef, let me ask you a question. This week, one of the last things that we were working was the steering wheel motor, and I didn't quite know that when you can assign to the motor the torque. So you can give the speed, the force to the motor from the Arduino. And I was thinking, because while I was talking with the guy that is working now for me, that I don't bring him to the meeting because he doesn't speak English. And I was thinking that maybe one of the things that we can achieve is to get using that the script to center the potentiometer. Because if you give him a very low force, not to break the potentiometer, when the motor will go to the end of the potentiometer, will I don't know how to say it, but will do it loosely so you don't break it. But you will know that you are in the far right of the potentiometer. So from them you can now go to the other side and put the potentiometer. Is that possible to calibrate the sensor with the motor?
You could, and as
or
you say,
that's something stupid.
As you say, you could do that by, and you made one comment, you can control the speed of the motor from the Arduino. Technically, you're controlling the amount of power to the motor, and then based on the load, that actually translates into a speed. So that's just if you sit and looking at it, you'll say, yeah, that is controlling the speed. But just keep in mind, you're actually controlling how much power you're applying to the motor. Now, back to your point, can you make it do that? If you were to lift up the front end of the thing so you have no load on the steering, then yes, you could give it a very small value and let it, which gives it small power, which moves it over until it hits a hard stop. And at that point, it'll hit the hard stop and just stop and not smash anything because you're not giving a lot of power. So yes, you could do that. Now with it sitting on the ground, now you've got more of a load on, so you have to give it more power to get it to move. And now you're getting up to the point where you would have to worry about if you run into the hard stop, is it going to smash anything at that point? So another way to do it would be measure the current on the motor. You could put a current sensor in there somewhere, and then say when it comes up and hits the hard stop, you're going to see the current go up, and you'll know you're at the end. Another way to do it, put some kind of a sensor on there, like say those magnetic sensors you're holding up. You can put one of those at each end, and if you come over and it activates that, you're at the hard stop, without actually banging into the hard stop. So you could do something like that, or put little switches on it somewhere. So again, you just need something to tell the computer that you're at the end of travel, and whether it's you actually run against a hard stop and it can't go any farther. Now the reason why that's important, say if the tractor is sitting on the ground and you've got the weight of the tractor and you say apply 10% power to the motor and it starts turning, it may stop just due to the fact that it's just the force on the ground. It can't move any farther, and you'll think you're at the hard stop, but you're not.
I didn't think about that.
So the next thing you could do there.
Think about
So what you could do with it sitting on the ground like that, and whether you're sitting, say, on a smooth surface like on your sidewalk, or if you're in the grass, it's going to take a different amount of power. But what you could do is apply just the small amount of power and run it till it says it's stopped, and then increase the power a little bit, not enough to damage anything, but just increase it some more. And if it starts moving again, then you were not at the hard stop. So there's different ways around that too. You can, by watching the numbers, you can tell what the thing is doing. If that makes sense.
Okay. Yes.
Because in reality, you're controlling the power of that motor. So it's up to you to decide what you want it to do. If you want it to turn left, then apply power in that direction and see if it moves. If it doesn't move, give it a little more power. And then if it keep going until it stops. And then another thing to keep in mind, once it does stop, you want to kill the power immediately. So you're not sitting there with the motor locked up, because that could burn it up. Or if you apply too much power against a hard stop, you could break something in the drivetrain. So it's just a matter of thinking about what are the implications going to be on that. But essentially that's what you want to do. You just want to apply power, say, to the left until it comes to a stop, and then assuming you're not giving it, don't give it full power and go to the stop, because that's, I think everybody understands that's a bad idea because it's going to slam into the side. At one point, somebody mentioned breaking the potentiometer. I'm assuming you can't break the potentiometer because your hard stop should limit your travel right and left, regardless of the potentiometer, unless it has slipped on you. If it has slipped for some reason, then you could possibly run it up against the end of the potentiometer and break it. But if you have a 3-turn potentiometer and your steering wheel can only turn a turn and a half, then as long as nothing slips on the potentiometer, you really can't destroy it at all. It's just a matter of you're going to bang the steering up against the hard stop. And I assume your vehicle is built to the point it can survive that.
I think that that's the point. I think that that's the point what you are saying. That's important. That's the point. Maybe I don't need to do the other thing because as it is a pre-term potentiometer, I won't have that problem. Surely the steering wheel will find out the end before the potentiometer finds it.
But it is still good to know, because if your potentiometer has slipped just a little bit, that you want your test to tell you that. So if you run, say, all the way to the left and all the way to the right, you're expecting certain numbers to come out of that. And if you don't get those numbers back, it says something has slipped, whether it's something in the mechanical system or the potentiometer has slipped a little bit. So yes, that's very valid to put in your test, that you want to do that. You want to turn all the way to the left and all the way to the right. You are expecting whatever numbers you got the first time. If you're not within like 10%, you'll say, well, we've got a major problem. And if it's in just within a few percent, maybe it's not going to be repeatable every time. I don't know.
No, but surely, but it will be something. I don't know, but maybe it won't be so different.
Now, another thing to consider on your test, the first thing you do is go out and read up the initial number, and it should be within the range of whatever left to right is. If it's not, say if you broke a wire somewhere, the number is probably going to be 0, or it's going to be whatever the maximum value is, which are both invalid values. So that tells you right up front, if you've got, say, a wire that has fallen off or broken or cut, it's going to tell you without even trying to move the motor, it's going to say, oh, gee, that's a totally wrong number coming off the potentiometer. So that's the first test you can do. And if that appears to be within the range that you're expecting, then you can go ahead and say, move it to the left and verify that end, and then move it to the right and verify that end. So there, several steps you can do there to determine, number one, does it have a problem? And then number two, that might give you an indication of what the problem is based on what numbers it was putting out. And then further down the line, you could get at the point where every time you start up your lawn tractor, say, just have a script or a node that runs, and it will just go through and cycle the steering back and forth and verify the values are right, and cycle the transmission forward, backward, verify you're getting the correct speed based on what you think it is. And so every time you go to run it, you can have that run. It doesn't have to be something you keep on the shelf. And when something looks bad, you run the script to find out if it's bad or not. Just every time you start it up, that could be a calibration step you could do. And along with that,
Yes.
once you verify the steering's working, you verify the transmission's working, then actually tell the thing to drive in a circle, and you could actually compare the numbers on the GPS to the numbers coming off of wheel odometry to the speed coming off wheel odometry. You can compare all that stuff. So every time you start it up, you could run that just as a calibration step to tell you whether or not things are working. And then
Yes.
like
we
Al's,
thought about that as a first step. But first of all, you have to check out the hardware. Then
Right.
you have to check out the information, and then you have to check up what you are saying, and that you are right to go.
And since you're just starting off on that, you are best just make it standalone right now and say, we just want to verify the steering. So you just have a thing that does that. And once that's right, then you could write another one to do the transmission. But I'm just saying later on, you could add all this in, when the thing's ready to go out and mow your yard, when you get to that point, you say, turn the switch on and go mow the yard. Then at that point, it could do these extra calibration steps, just, every time you go to drive, are your tires low because you're getting the wrong numbers, or, there's all kinds of things that could tell you. But yes, I understand right up front, you just want something simple enough to verify that your hardware is correct and nothing has slept on you.
Yes. Well, I hope.
And before we just go off on random things too much, we should ask Bob if he got his laptop and if he wants to discuss that before the meeting's over here. So
Okay.
well, we'll see what's going on with him.
Laptop, according to tracking, is going to come tomorrow. So I've
Okay.
been spending my time reading up on Windows and Teensy and really questioning how I want to set it up in the first place. Juan suggested some things on the Slack channel. When do I have to partition that hard drive to do that? And if so, how much space do I allow for Windows and or Ubuntu and all the rest?
Well, the first question is, how big a hard drive do you have? You
Oh.
posted the model of your laptop, but I went and looked, and you can buy it in like six different ways. So, and part of that is what size hard drive is going to come on. If you got a really big hard drive, I might. I guess my theory is, if you're going to use Windows and Linux a lot, I would partition it half and half if you got the space. Now, if you're just going to use Windows, I typically use Windows because I've got just a couple of programs that have to run under Windows. So I don't really need, a lot of space to do that. So when you go to install it, it's going to ask you something about how much room do you want. And I think specifically, if you go to load Linux on this thing, if you go to the site, let's say go to the Ubuntu download site, and it'll say, here's instructions on how to do this. And basically they will say, download this image. And once it's on your hard drive, it'll say, burn this to a flash drive. So you get a little plug-in flash drive, and they'll have the steps that say, burn this to the flash drive. And once you do, then you can plug that flash drive in and boot the computer, and it will actually boot up Linux from that flash drive. And once it's running, it'll come up and say, do you want to just run this to test it out, or do you want to install it? So you might want to go through the one that says you just want to test it out. So go through and verify that it starts up, and then you can get into it and you can figure out how to run Linux. And then when you think that's what you want to do, then you can go back there. There's either an icon on the screen that says go ahead and install it to the computer, or again, you can just shut the whole thing down. It comes up and says, do you want to install it or test it? You say install it. And then it'll come up with a series of questions. And one question will be, it says, do you want to erase your existing operating system and install Linux only? Or the next option is, it says, do you want to install this alongside of your existing operating system? So if you click that one, it will install Linux and it'll leave Windows there. And if you follow down that path, then it will say, how much space do you want to allocate to your Linux? So you can make the decision at that point. Now, if you have a small hard drive, I would say just leave maybe, I don't know, 25% of the space for Windows. Part of it is you're gonna have to look to see how much room Windows is already taking up. And I think if you go under Windows and click on the drive C and say properties, it'll say, here's how much room we're currently using, how much hard drive space is currently being used for the C drive under Windows. And that'll give you an idea right there. Now, if you got a really big hard drive, I thought you could get 256, 512, or 1 terabyte hard drive with that particular laptop. If you got a 1 terabyte drive, it's not that big a deal as to how much you allocate to each one. So if you get to that point and you say, I want to install Linux alongside of Windows, and then it's going to start down the process, and it comes up and gives you an error, say, oh, I don't have any partitions or something, because it will do the partitioning for you. But if you have an HP computer, they decided that they're more important than you are. So it turns out you can have 4 primary hard partitions on a standard hard drive. But the people at HP said, oh, we've got Windows installed on the first one. We'll just take the other 3 and we'll use them for random stupid crap, so nobody can do anything else with it. So they'll have a Windows backup partition. They say, if you want, you can, one time only, you can take that and copy it out to a flash drive. So later you can reinstall Windows if you want to. And once you've done that, you can't do that again. So you can just delete that partition. They have another one called HP Tools, and they took up an entire primary partition for that. It was just a little tiny thing that they put on there. I can't remember what they did with the third one. But the point is, they've blatantly screwed you right out of the box. You have to go through and clean that stuff out and delete those partitions before you can install Linux. So that you might run into that. And I can't remember what the error is, but that's a common thing. So since it's an IBM, I don't know if IBM is smart enough to not screw you right out of the box or not. So I guess we'll all find out when you get that far.
Yeah, I like the idea of using a thumb drive or flash drive and test, because I haven't done any coding in years. So I'm starting from scratch, literally from scratch. So thanks a lot.
This isn't so much
Yeah.
coding. That's just the way you install Linux these days. You download the image. Is how you can download it using Windows. You could download it using your Macintosh, and then they'll have instructions that says plug in a thumb drive, and whatever computer you're on, they'll say this is how you burn that flash drive. So you could go look at that right now, and you could start downloading your Linux image right now, before your computer even shows up. So
Okay.
I noticed it said they have.
There is only one thing that I think that you have to regard, is that some computers got something called UEFE, that is a special boot situation that you have to do some workaround from the BIOS, because it doesn't let you install another system. I have that problem with my computer. I'm not sure if you are going to have it. I think that you will have it too. So maybe you end up the installation and it won't let you see that you got the Ubuntu installed.
That's a good point. The last one I tried to install, that bit me on that too. So you have to go into the BIOS, and it's called whatever that was, UFES or whatever. And that's a special thing to prevent viruses from trying to install another operating system without you knowing about it, is why that's there. And it could be you could do it right, but I just said turn all that crap off and went ahead and installed my Linux on top of it. And there may be a couple more BIOS things that come up, but it might be easiest once you get that far. If you run into something that says that you can't continue, then we can specifically look at that and see what you got to do. But it's not like 5 years ago, it was fairly easy. You plug it in and say load it, and it works. And then as they keep adding all this new stuff on, it becomes harder and harder to get this stuff to work. So but that's still a way you can go. Now,
Okay.
The main problem that I got with the installation was the thing that is saying chef. I got problems with the UEFE, but there is a lot of information how to solve that. Maybe you can begin reading, and you will find out. One thing that I recommend to you is not to erase up the Windows system. I have done that because I'm a Linux user from, I think, 5 or 6 years to now, but that was a mistake. I didn't need to do that, but I did it, and that was a big mistake, because there are some kind of software that are really better in Windows, like the 3D printing design software, like Rhino and those ones, and in Linux are pretty shitty software about CAD and that kind of thing, or 3D. So, and one thing is that if you got very low space, it's better to give more space to Windows than to Linux, because you won't install a lot of software in your Linux machine, and the software is much smaller and lighter than the software in Windows. So if maybe you got 240 gigabyte disk, it will be appropriate to give 150 to Windows and 100 to Linux. Always give more space to Windows than to Linux. Sorry, Chef.
Along that point, yes, if you don't have to erase Windows, don't, because it's just easier to have it sitting there not using it than try to go back in the future and put it back on there. The other thing about the hard drive size, yeah, I'm not sure exactly, how much you need one way or the other. So that's why I was originally thinking, 50-50, but yeah, if you've got a small enough hard drive, you might want to start thinking about how to do that. And right offhand, I don't have a Linux computer in front of me, so I can't tell you how much space I'm using right now. But yeah. So, but anyway, back to the point, if you try going down this path and it says, I can't continue for whatever, either look it up and try to solve it, or say, it's telling me this, what do I do? And maybe we can tell you, because, somebody was, oh yeah, that's gonna happen too. Cause I don't remember right offhand what they were. I just went through and installed it several times here a couple of months ago, but I don't even remember what the problems were. I just know HP is a problem. And, I think HP and Compaq are the same company now. So probably either Compaq or HP is going to do the same thing to you, like this nonsense that they shouldn't have done. And I don't know about IBM, if that's going to do that or not. But anyway, back to the point. Yes, you can go out and you can download your Linux image right now. And before you download a Linux image, you have to know which version of Linux do you want. And to know that, you have to know which version of ROS are you going to run. So if you're going to run the kinetic version of ROS, which is what the Ubiquity image is built on, that way you'd have the same version. And I think everybody else here is running the kinetic version. So if you go with that one, then you have to pick the correct version of Linux, which I think is 1604 is what you want for that. So when you go
Good.
to download it, you have to pick, I believe you want to pick the 64-bit version and pick the 1604 version, and then say download that image, and they'll give you fairly good instructions on how to download that on either Macintosh or Windows or Linux. And when you're all done, it'll say now burn that to a flash drive. And again, based on your type of computer, they should tell you how to burn that image. Now,
Okay.
your Macintosh, is that a real Macintosh? Is that like a tablet type computer?
No, the one I have access is just an iPad. My wife has
Okay.
a Mac laptop, but I don't want to take any chances with her machine.
So I don't know if you can go ahead and download. Yeah, it might be best just wait till you get your laptop then and fire up Windows and go through those steps and download the thing and do everything you have to and get all set up before you try and start trying to install Linux. And once you get that image downloaded and that drive created, you can just plug it in and boot from that, and then you can run Linux, play with it, see what it's going to do before you even try installing it. So that'll give you a lot to do before you jump into it.
Okay, sounds good.
Now, a totally different option, you had mentioned somewhere along the line, or should you install one of your operating systems to a flash drive and just boot from that? I wouldn't attempt to actually run from a flash drive, but if you're to get a real external hard drive, whether it's the old mechanical type or the a solid state drive, you can plug that in through USB. As long as you're going to leave this laying on the table so you don't mind having this thing dragging along beside you, you can actually plug in a whole brand new hard drive. And when you say install Linux, it says point to that drive. And I think you can install it to the external drive. And then when you're done, you can just unplug it. And then when you want to run the Linux, plug that back into the USB and boot up and have it actually boot and run from that external hard drive. So that would be another option you could do. But probably the easiest way to start off with is just go ahead and with your computer out of the box, get to know how to run that external Linux, and then say install it and go ahead and just run it that way as a dual boot system. So every time you turn it on, it's going to pop up and say, oh, do you want to boot Linux or do you want to boot Windows? And you tell it which one you want. Usually it'll default to Linux. And then you have to, within 10 seconds, you have to say, no, go to Windows instead if you want to boot that. But that'll get you started, and you can start playing with it and see how it's going to work out. Maybe that's all the advice I have until you try it.
Something that you can do that will make this easier is not to cipher your folder, your personal folder by now. Maybe in the future, as life will go on, you will install Linux a lot of times. But the first time, try not to cipher your home folder, because you won't have much problems about security. But when you got that cipher, it's very hard to recover that.
You're saying
Okay.
cipher. He's saying don't encrypt
Cipher.
your drive, which I never encrypt my drives. So that hadn't occurred to me, but yeah.
Yeah, okay.
So
Good.
if you want to encrypt, don't do it up front. You know, wait for a while before you get around to that, because
Yeah,
that'll just cause problems.
right. Well, all good advice. Thank you very much. I'm gonna need a lot of hand holding.
We will try to help.
And
Okay.
something you might want to do is go to Google and specifically type in, I have an IBM, Lenovo, whatever, and say, I want to load Linux on it, and see if somebody will take you through the actual steps for your computer to load it on. If you can find something like that where somebody else has done it, they may have identified all these problems. They can tell you right up front what you're going to run into. So that'll give you a better idea too.
Good idea. Thank you. Hey, guy.
Anda. ¿Quedó algo helado? I will have to go with the kids. So, bye.
Yeah.
See you next.
Ciao, Juan.
Thank you.
Jeff, anything else?
No, I don't think I have anything else.
No more progress on your mechanical side?
No. What's this other link that got posted from Al?
I had written instructions before on installing ROS.
Oh, okay. Yeah, it's that thing you were talking about before. A note to Bob if he's still on. Looks like he
Yep.
is. That first thing I posted in the chat there, you were talking about something about looking at the Ubiquity image. Well, it turns out there's tons and tons of crap loaded on that you can't see. You can't see it simply because you don't know where to look. But if you type in this ROS pack list-names, it'll show you everything's loaded on there. You're going to turn out there's hundreds of packages already loaded on there. And the reason you don't know they're there is because they're not under your home folder. They're under /ROS/opt/ opt/ROS/ probably
Good gravy.
kinetic. And then once you get out there, there's a folder called share and one called lib and one called something else, bin, I think it is. And even looking at those, you can see there's hundreds and hundreds of files there, but it still doesn't really tell you what you need to know. So if you use this ROSpack list command, that'll actually give you the name of the packages so you can see what's out there. It'll be packages like navigation and slam and joystick and all the packages that are on there. And you're going to find there's hundreds of them out there, even though you don't see it right up front.
Okay.
At the most, what you're going to see right now, they might have supplied you with a couple of launch files, but those launch files know those packages are out there, and that's why everything works. So that's just one more thing to keep in mind. There's probably other ways to find out what's out there, but before the meeting, I just looked that up to see. If you just type in, if you got your computer fired up, you put ROSpack, and I think you say ROSpack help. It'll give you all the commands you can do under ROS. They'll tell you all about your packages. But this is going to be a very important one, just so you know. Yeah, there's a lot of crap out there, and you don't have to go through and load everything from scratch.
Okay, good.
And one other minor point. Anytime Walter gets on, he said, "Oh, but how do I compile this stuff? Do I have to cross compile it? Do I have to compile it here? Do I have to put it on the Raspberry Pi and compile it for 4 hours?" Well, the point is, you don't have to compile anything. Don't assume you have to compile all this crap from scratch. That's what the Debian packages are all about. So you're going down a tutorial that says, "Oh, load up the joystick." So you just type in sudo apt-get install kinetic joystick, and it goes in and grabs the binary file for that particular computer and loads it in, and you're ready to go. You don't have to compile everything from scratch like he seems to think he needs to do. So if it's the point you think, "Oh, I got to go compile everything," you're doing the wrong thing. So just keep that in mind.
Okay, good.
Most of the stuff you say, if you want to run it, you just say install the package. It's okay, it's installed, and you're ready to go. You don't have to do anything major
Nice.
beyond that. There are a couple of things. If you're writing your own code, if you're writing your own node, or you got a node from somebody that you're going to modify it that was, say, in C++, then you do have to recompile that every time you make a change to it. But in the real world, no, you don't have to go and compile the entire world of ROS. And if you are, you're doing something drastically wrong.
Okay, good. Thank you. Nice to know.
That's all I can think about right offhand. I have no more words of wisdom today.
Any more progress on the physical front? Jeff,
On the what?
on the physical front?
No, I've got nothing done this week. But my paint had yet another week to dry, so I always have the rule. I've learned that if you use spray paint, you got to let it sit for at least 2 weeks so it doesn't just scrape off when you look at it. Or if you bolt two pieces together, once you do and you take them apart, it peels the paint off. Well, if you wait, I decided at least 2 weeks, you got a good chance of it not doing that. And I've put this off. It's been at least 3 weeks now. It's still the paint. It's still hanging on a shelf upstairs, so I could start bolting things together at this point without having to immediately scrape all the paint off. So I'm in better shape there.
Could a guy use a heat lamp to cure the paint?
I've even at times turned on my oven to like 200 degrees and put it in there and left it in for several hours. And yeah, there's lots of things you can do, but if you don't need it, just hang it up and let it dry for long periods of time, and it'll take care of it. Usually I'm in a big hurry, and as you say, if some external method, either heating it or blowing air on it or both, yeah, you can get it to cure quicker, but it's still not going to be. It still really wants to sit for a long time and let all the solvents evaporate out, and then you'll have fairly decent paint at that point.
Okay.
Bob, anything else on your end?
He must have missed that.
Bob, anything else?
No, I got a lot to think about. Thanks.
Okay, guys, well, have a great weekend. We'll talk to you
You
later.
also. Bye.
Okay.